In this video, we're going to cover the differences between the integrability of even versus odd functions. Specifically, we're going to look at a special case in terms of the Gaussian integral. We have here that given that the integral from 0 to infinity of e to the negative x squared in respect to x is equal to the square root of pi over 2. Given this information, we are asked to solve the integral from negative infinity to infinity of e to the negative x squared in respect to x. So how should we go about doing this? Well, consider that if we evaluate a function f of negative x, if that ends up equal to f of x, then we have what's called an even function. If, however, f of negative x is equal to negative f of x, we have what's called an odd function. Now, the beauty of the exponential function in this case, e to the negative x squared, if we plot this on the xy coordinate plane, otherwise called Cartesian coordinates, we plot the function f of x equal to e to the negative x squared. We get roughly a normalized distribution here. We call this a Gaussian distribution. Now the integral from 0 to infinity of this function would be this area right here. Let's call that I sub 1. And that equals the square root of pi over 2. Now we're asked to find the entire area from negative infinity to positive infinity of this function e to the negative x squared. So we're going to then have to add the same amount of area on both sides. And this is only true because we have an even function. If this was an odd function, negative contributions from the left side or on the right side or vice versa would cancel each other out to yield 0. So that is all to say, if we have an even function, then the integral from negative a to a of some function f of x dx is going to equal 2 times the integral from 0 to a of f of x dx. And as such, if odd, then the integral from negative a to a of a function f of x dx, the negative and positive contributions of area cancel out exactly, giving us 0. So given that e to the negative x squared is an even function with the same amount of area on both sides, symmetric area across the y-axis, so now we can say with some clarity that given that e to the negative x squared is an even function, this must equal 2 times the original integral that we have, if we were to call this integral here I. So 2 times I is just the same thing as adding I sub 1 plus I sub 2. But that's just the square root of pi over 2 plus the square root of pi over 2. So our integral must then be equal to the square root of pi. And that's all we have.